Copernicus is Europe's Earth observation program for monitoring our planet. Its Sentinel satellites track the changes in the environment to support safe and sustainable human activity and the effects of climate change. The polar regions are some of the most dramatic and sensitive areas that require specialized satellites and information. The key environmental monitoring for polar latitudes and European Readiness project, KEPLER, has been funded by the European Commission's Horizon 2020 research programme to develop a roadmap to improve and better integrate the different components of the Copernicus monitoring programme. Here we provide 3 examples showing how the next phase of Copernicus, from 2022 to 2028, called Copernicus 2, can deliver on the potential of its current and new satellites and information. By using products from Europe's Earth observation programme and building on Kepler's recommendations, the possibility of a successful outcome is enhanced. During spring, in a vast mountain plateau in Norway, a Sámi reindeer herder tends to his flock in pasturelands known from indigenous knowledge for the quality of their grazing. A service based on the weather forecast and Copernicus Earth observation data would send an alert to their mobile, advising that a low-pressure system with freezing rain is approaching. This will cause the pasture to be frozen over and prevent the reindeer from accessing the lichen. Based on this new knowledge, the herder could decide to move his reindeer to pastures in a nearby fjord away from the freezing rain. He could check the app for the latest information on avalanche risk and for the safety of fjord ice and move his reindeer by the safest route. Later in the summer, near Svalbard, a research vessel wants to navigate a safe course from Longyearbyen to an oceanographic mooring site north of Fram Strait. Whilst most of the sea ice in this area is young and thin first-year ice and easily within its capabilities, there is a risk of old ice that has survived several seasons and is extremely tough, as well as ridges, both of which are dangerous to the ship. Mapping from Copernicus Sentinel-1 satellite data and forecast model predictions for the next few days show that the ice will steadily drift to the southwest. Using this information, they plot a route through the ice field to the site. Sub-kilometre scale detail on the sea ice cover will allow the ship to navigate safely and efficiently through the ice and recover the mooring instrumentation. Nearing the end of the year, winter and polar darkness descends on the Arctic. Suddenly, a voice is heard over the emergency radio on Channel 16.
Mayday, mayday, mayday. It is Alpha. Our position is 79 degrees, 50 minutes north, 20 degrees, 10 minutes east. We have run aground on Nordoostland and are sinking. With 10 people aboard, we require immediate assistance. Over.
A lone trawler has been working the waters close to the coast north of Svalbard. An engine failure has resulted in it drifting onto a rock. In addition to the radio message, a satellite emergency position beacon alert from the ship is received by the Joint Rescue Coordination Centre in Bodø, Norway. Using the latest weather information and the latest position of the ship, a search and rescue mission is launched and a helicopter picks up the trawler's crew. Soon afterwards, a Coast Guard icebreaker approaches the wreck, guided by the latest sea ice information. The latest satellite data are combined with Copernicus data simulations to allow the captain to determine the location and potential drift of any escaped fuel, facilitating its prompt removal. In the following summer, a salvage fleet arrives, guided by the latest weather and sea ice information, and sets about removing the sunken fishing boat. These examples of some potential user requirements in the polar regions show what improved information services could be possible when there is an uninhibited flow of information of Copernicus 2 products to the users. Kepler's roadmap will provide a guideline towards a comprehensive European end-to-end operational system for Earth observations within Copernicus 2.